Thank you so much for joining us. We are here at Success Academy's Robertson Center, presenting you from Success Academy's Robertson Center to share all about the real value of math class. I am so excited for today's conversation. I wanted to start with a quote from a book that I recently read from one of our panelists here. It's called Dear Citizen Math, and it's written by Karim, who you see here. It says, when given a choice, we tend to learn something only when we care about it. In order for students to be willing to make the effort to master mathematics, they must first have a reason. And I think that kind of puts into perspective a lot of why we are here today. We know that math class, we've probably all been in one end of a conversation, either the receiving end of, why do I have to learn this? Or we've been asking someone else, why do I have to learn this? And I'm really excited to have the folks you see here on the screen today to talk about just that topic. If you have a moment, we are excited to see you here today. We would love for you to introduce yourself in the chat. Use that chat liberally throughout the session. Feel free to share your thoughts, your ideas, your questions. You can also go ahead and use the Q&A to put any questions that you have that you want answered here today. We'll make sure that we save time at the end to get to as many questions as we possibly can. In just a moment, I'm going to turn this over to Dr. Harris, who you see on the screen today. Then we're going to bring it together for everyone. We're going to have a panel discussion with everyone you see here. And then again, at the end, we'll save time for those questions. So make sure if you have a specific question that you want answered, put it in that Q&A. We'll make sure we do our best to get to that. So I will quickly turn it over to CEO of the National Math and Science Initiative and NASA astronaut, Dr. Bernard Harris.
Thank you, Stacy. It really is an honor for me to be here today to participate in this. And I'd like to thank the Robertson Center and Foundation for all of its efforts around math and science. Just by definition, Stacy didn't introduce me, but I'm a physician. I'm also an astronaut. I've flown 2 missions, traveled over 7.2 million miles. And before you ask that question, did I get any frequent flyer mileage for it? Not at all. But just the fantastic opportunity to go and see the Earth and from that viewpoint that very few people have done has just been fantastic. And that's reward in itself. I'm going to share my screen here because, I can't be an astronaut without sharing with you what I call my home movies. And I wanted to do this in a way in which to, I hope you guys can see that. Let's see if we can try that again. Can everybody see my screen? Can somebody just give me a thumbs up? Oh, fantastic. All right. So what I'd like to do is to give you a little bit of my background, a little bit more than what I just said a second ago, as a foundation for our discussion today on math. And I call my presentation today the Math Challenge. And I hope that you will find at the end of my presentation that we do have a challenge in this country around how we educate students in mathematics. I'm a big advocate for STEM education. And I have to remind people all the time, even my folks that I'm involved in the venture capital business, that finance involves math. Math is involved in everything that we do, and we forget that. But for me, it started when I was 13 years old, watching Neil Armstrong and Buzz Aldrin land on the moon in 1969. And when I saw these black and white images, I was fixated with space. I already loved space and science fiction, and just captured my imagination and really put me on my journey to become a physician and then an astronaut. In 1990, I was lucky enough to be accepted amongst 23 others into the 13th class, the astronaut class. And most people don't know this, but we go through a year of basic training and then another year of mission specific training before we are really qualified to go into space. And so after I finished my training, I was ready to go up. I got assigned to my first mission. And then a few years later, my second mission. And what I'm going to show you is the launch of my second mission, which was a mission to go to the Russian space station. Now, I'm going to talk like I'm an old man here. Back in the old days, we flew the shuttle program, but as you know, we have other vehicles in order to get into space these days. But the shuttle is an amazing vehicle. It weighs 5 million pounds. In order to get that 5 million pounds in the air, we have to light 5 engines that produce a thrust of 7.5 million pounds. Let's watch it take off.
Liftoff. We have liftoff. Houston now controlling. Houston shuttle, roll program. Roger, roll maneuver.
So
Already 7 miles away from the Kennedy Space
So think
Center,
about that, a few seconds, 7
miles.
miles away, that's a lot of power there. So 7.5 million pounds of thrust gets you into space pretty quickly. Within 2 minutes, we reach our second stage where we drop off the external, the solid rocket motors. Those motors fall back in the ocean, are recovered. And then another 6.5 minutes, we are safely in orbit where we kick off the external tank. And now we're about 250 nautical miles above the Earth. We kick off that external tank and we fly away from it, and it falls back into the atmosphere and actually burns up on the way in. But by that time, we're safely in orbit, traveling a mere 17,500 miles an hour. And before I show you some slides of life up in orbit, I want you to take a look at 2 slides here. The one on the left is a crew on the ground taking our official public relations photo. And you'll see that in this mission, we're all smiling, happy to be going up. We're also showing you 2 types of suits in which we use in space, our launch and entry suits. So the orange suits down below weigh 120 pounds. And the suits at the top are our EVA suits, extravehicular activity suits, and they weigh 350 pounds. I know as you look at this slide, you may say, golly, you must be strong standing up in that 350-pound suit. But the reality is that even though there are only 6 people depicted in this slide, there are actually 10 people in this slide because there are 2 people holding me up in the back and 2 people holding up Michael Fold as we're in gravity. So if you then slide your image over to the right, you'll see us on orbit. And one of the things you may notice is that our faces are puffy, our eyes look a little bit closed. If you look at the young lady that's on the first slide that's right below me, that's Eileen Collins. She is the first female pilot and later commander of a space shuttle mission. And look at her here on Earth, and then switch over to the right and look at her here on orbit. And you'll notice that she gets this instant afro. But the puffiness in the face is the first sign of my business as a crew medical officer, and that is space medicine. So we lose about 1% of bone per month. We lose about 1/5 of our blood volume. Our heart shrinks in size, and I can go on and on and on. But a real way in which to kind of demonstrate the effect of microgravity as it impacts all the things that we do is this slide of a good crew member of mine, Marsha Ivins, who shows you that microgravity affects everything, every physiological system in our bodies, and our body adapts to that environment, including our hair in this case. So as a physician, it was my job to make sure that the crew was safe on orbit. And so here I am examining one of our crew members. And we have, when we're in orbit, it provides us an opportunity in this microgravity laboratory to experiment on many different things. And we've learned a lot through the years. Just to put a little pin on math, of course, we couldn't even get in orbit if it wasn't for the mathematical calculations that's necessary for us to be in orbit. My job on this mission, of course, our job on the mission was go to the Mir space station and set the stage for the International Space Station, which is depicted in this slide. If I go back one, if you look at this slide, you'll see the Mir station, which was the Russian station. It's about a football field wide with all of the solar panels and all that. If you go to the station that we have above us now, the International Space Station, it's about 2 football fields. and the internal volume of a 747. So as dramatically different from the shuttle, which was a small, and some of the capsules which we're flying in these days are much smaller. This is like the Taj Mahal. It's an incredible opportunity and laboratory in space. Thought I'd show you just a couple of slides on orbit, and this is a view at night of the Earth. You see part of the International Space Station, just gorgeous. And another view looking off into the horizon at Aurora Borealis. And then lastly, in my space slides, I mentioned a minute ago that we travel 17,500 miles an hour, but I didn't tell you that means we can go around the world every 90 minutes, sunset or sunrise every 45 minutes. And I'd like to show you a sunrise from space. It is an awesome thing to witness. And in the time that it took me to cycle through those slides and give my little conversation here, that's how fast the sun rises. And the temperature will go from minus 165 to over 200 degrees Fahrenheit. So our systems, all those things have to take into account that change in temperature as we stay in space for upwards of 3 to 4 weeks, and now International Space Station, we're staying at upwards of 6 months to a year. So what does the future hold in space? It is expanding on what we're doing on the work in the International Space Station. By 2025, we're planning our first missions back to the moon. By 2030, we're planning our first human missions to Mars. So think about all the technology that's going to be required for us to get there, and that's available to us now. If you have been looking at prime time these days, you know that the private industry has gotten involved in space, and I'm excited about it because now we have not just one way to get in orbit, but we have 3 ways and more to come. We'll have orbiting laboratories, which will change not only what we're doing in space, but what happens here on Earth. And speaking of on Earth, there are a lot of things around technology that impacts all of our industries here on Earth. And the question that I have as you kind of glance at the slide of all the corporations that are involved in high tech, and then at the bottom of the slide, some of the new initiatives like quantum computing that are going to change how we do day-to-day living here on Earth. And the question is, are we prepared for that future? And more pointedly, are our students prepared for that future? And I would take a poll, and I could tell you that I've asked this question all across the country, and the overwhelming answer is that we are not prepared, at least not as prepared as we should be. And so in lies our discussion today around STEM and particularly math. Now, the National Math and Science Initiative, which I am part of, was started because of a committee report that was done by the National Academies many years ago, where it found that in the 21st century, math and science education was at the top of the list of the things that we should be focused on. It should be our going concern. It was our going concern then, it's our going concern now, because of the technology innovations required. In order to innovate, we need to upgrade and accelerate our nation's educational outcomes. And so my company is part of that initiative. And just to put a finer point on it, let's talk about math. Let's talk about assessments done today. And I'm sure that most of you are familiar with the National Assessment of Education Progress and the nation's report card. I just wanted to, I pulled out a couple of things in this report card that I just want to emphasize. So as I kind of go through the things on the left, take a look at the right at our scores in mathematics. And so what you'll find is that the achievement gap in math between students of color and white students is increasing, and it's not getting better. And if you look at, since the original time in which this organization was doing testing in 1978, there was a steady increase, a trend up until of recent. And so that is alarming, and that something has happened, something has changed that has resulted in those scores that you see there on the right. We have a population, particularly the population of students that have not performed well or performing even worse. And so that says to me and brings into the question, how is math being taught? Is it being taught in all of our schools? I know for a fact, if we look at STEM as a category, there have been a lot of changes and de-emphasis on the sciences in some areas. And those areas in our business, we call STEM deserts. And so part of that STEM desert that we're seeing playing out in this report is also a math issue in that. So we need to address how we're training our teachers. We need to address how we're preparing our students, because math is critical. And just to close out, our mission in NMSI, National Math and Science Initiative, is to reach those furthest from opportunity, to make sure that we can close those gaps that I just talked about. And we do that through a myriad of programs in which we categorize, put under the umbrella of NMSI 365, meaning that we have programs geared for helping teachers and helping students. We have teacher preparation programs. We have an emphasis on schools that focus on military families. And of course, with COVID, we had to react the same way that a lot of programs have had to react, and that is add a virtual component to our face-to-face trainings. And so we're in the middle of this. We've done good work in the past, as reflected there on the right part of the slide, but we have a lot of work to do. So part of our initiative and part of my reason for being here today is to help gen up this campaign around the power of STEM. And I believe that STEM empowers everything that we do, from opportunity to education, to inclusion, to social justice. It's not just learning math for math. It is important because it is integrated into who we are as a nation. And of course, as an astronaut, I have to say who we are as Earthlings. And so it's important for us, I hope in this discussion today, to realize that we are involved in teaching young people not only about the impact of education, but helping them realize that through education, that they have infinite possibilities in life. And with that, I'm going to stop, and we can get into our panel. I'm going to turn it back over to Stacy. Thank you very much.
Thank you, Dr. Harris. That was fabulous. And I love that infinite possibilities that we all have. I actually said that to my 8-year-old son today. Well, we've got our panel here, and it's great to see everyone, and let's introduce you. So I would love to hear, we just heard from Dr. Harris, the purpose of math class, right? I want to hear from everyone else. In your opinion, from your perspective, what is the purpose of math class, which I know is a really big question. So we just want to hear your elevator pitch. Sorry, I should tell who should speak first. Karim, let's pitch it to you.
That's a great question, and thank you guys all for having me. This is quite a treat. You know, I believe that the purpose of math class is fundamentally to prepare the next generation to be able to think rationally about the issues that we face as a national community, and to be able to use mathematics as a tool for analyzing those issues and learning how to debate them and ground our reasoning in something substantive. And mathematical analysis is certainly a really powerful tool for thinking critically about real issues.
And Steve?
So I think that Karim is absolutely right. I mean, the purpose of math, going a slightly more detailed look at it, is to develop the critical senses of quantity, how much, change, how are things changing and adjusting, chance, all of probability and uncertainty, data, shape, and measure, all as students are actively engaged in reasoning, applying logic, constructing viable arguments. That's what we ought to see in a math class. It's not kids regurgitating things that can be done by Google and by Alexa, but it's done by presenting students with context, with situations, with stimuli, with problems that give them a chance to make sense of the world that's around them. And, I just think that what we learned during the pandemic is the sole purpose of all of school is to help create a world that's smarter, greener, fairer, more equitable than it's been before.
Great. And Laura?
Two hard acts to follow here, and I would echo both of what they said. I really see math class as an incubator and a place where a mathematical lens can be developed for which you can view the world through. So I think, I think about my own experience, and I don't actually think I had that. Math was this thing that I learned, and it wasn't a way to look at the world. And I truly believe that it is a way to look at, make sense of the world around you.
Great. Well, we're going to dive right into the conversation. I'm really excited to do so. I have a lot of questions. I know we're not going to get to all of them, but really excited for you to converse with one another. I know it seems as though we've got very similar opinion about the purpose of math class, but I think we have a little bit of different perspectives on how that is done. And so we're excited to kind of hear that today. So let's start by talking about just that. Tell us about your ideal math class. What should math class look and feel like? How should it change or shape student thinking? That's a big question. Feel free to take one part of that or all of it, but really I want the description of that ideal math class, either that you've actually been in or that you have envisioned in your mind. And Steve, why don't we kick it to you first?
Well, this is a little unfair because I spent last week in Northern Vermont, actually in school with students and teachers for the first time in 19 months. I can't tell you how excited I am to have had that experience. I used to sit in 150 math classes a year, including a whole lot at Success Academy, and it's been a long time. What's an ideal math class? I walked into a 9th grade math class where the teacher put on the interactive whiteboard a table of data and said, what do you notice? What do you wonder? And the kids all said it's going up. And another kid says, it seems like it's going up faster. And the teacher asked, what does that mean? And so the teacher said, what can we do with this? And the kids all said, well, maybe we can graph it and see a picture of it. And so then they end up with a picture of it, and they start talking about what it could be. And the teacher says, well, I'm going to break your bubble and so we tell you that it is Vermont COVID data for this period of time. This is the number of cases. Cool. Turn and tell your partner, what is the summary of that data? It's an ideal math class because it's accessible to all kids, because it starts with real data, because it starts with something that the kids are interested in. And I'm just going to abbreviate all this because what it then ended up going is every kid had Desmos on their iPads and on their Chromebooks. The kids all entered that table. They all went from the table to a graph, and then they started worrying about, was it linear? Was it exponential? And I watched 19 kids thoroughly engaged. They cared. The teacher was forever asking, so what did you learn? What do you know? What could it be? How do you know? And then when that was all set, the second set of data wasn't so obviously exponential. And to listen to this discussion of, well, if only we had one more piece of data, then we would have a clearer sense that it must be exponential, or lo and behold, it is linear. And to me, go ahead.
So do you mind if I jump in, Steve?
Please, I was done.
Yeah. So I agree with part of that, and I disagree with a lot of it also. So here's the part that I agree with, is in your kind of telling of this ideal math class, you were focused on, and I imagine the teacher was focused on, and certainly the students seemed like they were focused on kind of the underlying mathematics, the relationship between a table and a graph and maybe an equation and the shape that the data makes. But what's interesting, and I think that's really good, right? I mean, that is effectively treating mathematics as a set of tools, a set of concepts to look at. What's interesting to me, though, and I think
and this is so you're clear, and then creating the linear expression and the exponential equation, which, as you well know, is a missing skill for many students. Yes, still a skill, but an understanding. Go ahead.
Sure, but I think the part that's missing, and I think this is the part that has historically been missing from math class, is in your telling of the ideal math class, and I'm sort of using you as the representative of what I think a lot of people define as the purpose of math class, or a complete math experience, is in your telling, you never actually said what they were talking about, what the data was. And so I think that is part of a really important math experience, like looking at mathematics. Oftentimes we use data almost like as just the thing that we're using in order to look at linearity or exponential growth. But the part that I think has always been missing from math education is, again, that is treating mathematics as something to look at. But what I think was really valuable about what Laura said a moment ago was math is also a lens to look with. And that, I think, is the piece that has historically been missing. So, you know, we can make up data. I mean, textbook publishers have been making up contexts forever, right? To get kids to look at, oh, that's exponential, or oh, that's logistic, or oh, that's proportional, or whatever. But the contexts are totally artificial. And that's fine if our goal is for students to sort of understand mathematics as a set of concepts and mathematics as a set of skills. But I think where we have historically missed out, and I think this is why kids continue to ask, why am I learning this, is because we rarely turn those skills around, exponential growth around, and really look at the real world. And I'll give you just a very quickly, during the pandemic, you mentioned the pandemic. Early in the pandemic, I saw something in the New York Times, right? And it was in the education section of the New York Times, and it was a headline that I think is really telling about what we prioritize in math education, and what I think our Achilles heel is. And the headline was, "Teaching Statistics Using the Coronavirus Pandemic," right? Think about that for a moment. Using the coronavirus pandemic, using the worst medical tragedy in 100 years to get kids to understand statistics. Like, that is totally backwards, right? Statistics, exponential growth, those are the tools that allow us to understand the pandemic, right? And so I think that inversion, and as a community, our historical kind of reluctance, maybe, or inability, I don't know what it is, to make the distinction between looking at math and looking with math. I think you put both of those things two things together, I think that's when you get the ideal math class.
Laura, what do you think?
I happen to agree with Karim here. I think that, and I was going to say something, a version of this, right? That it has to be both. It has to be a place where you can have fun with numbers and find joy in doing something that has no context, right? Like, I'm thinking about a number string or a true false number sentence. You have to be able to find joy in that and find it interesting in the patterns and the way that numbers work and how amazing it is that they can help you reason through situations. But then I do think, coupled with that, I really liked what you said, Karim, about using mathematics to understand situations in the world. And I think you're right. I even think the way we generally approach it is to use the context to get at the math. And you're saying the opposite, which I think is actually very insightful.
So can I jump in here? Because
Yeah.
I'm kind of the practical guy, right? If I was to truly admit it in front of all of the audience, math was not one of my strongest courses, right? I struggled with that. And it wasn't until I could figure out some relevancy to what I was being taught that it became pretty clear to me. So as I listened to the arguments, you know, I'm like Laura, with you have to have both. I think we're all saying you have to have both. But help me understand, and maybe this goes to Karim, is how do you flip it and still make it so that it's accessible to the students and that they can relate to it? Because if you can't relate to what's being taught, then it's not going to stick. At least that's my opinion.
Yeah, I think that's a great question. I mean, I think we have hundreds of years of evidence that the way that we've been teaching math hasn't related to students, right? I mean, to the extent that most people on the planet would say that they don't understand why they're learning this. But, you know, I think it's a great question. And I think the world is relevant. And so if I were to ask you, what is the likelihood? You're probably the most appropriate person to ask this, right? Like, what is the likelihood that humans will communicate with some alien civilization, right? So when you look at the Drake equation, which is what astrophysicists use to answer that, like that fundamentally is answerable using fraction multiplication. How many stars are there in the Milky Way, and what fraction of those have planets, and what fraction of those planets have inhabitable climates, and what fraction of those will give rise to life. And so the thing that we're looking at in that situation is, what is the likelihood that we will communicate with an alien civilization? And mathematics is the tool that we use, the telescope that we use, pardon the pun, to kind of look at that. I don't think, in my experience, you don't really need to do much of a sales job, right, to students to convince them that that is a question that is worth answering, right? Like, should people with small feet pay less for shoes, right? Do we see evidence of climate change? Should McDonald's rewrite its menu in terms of exercise? Should Major League Baseball stadiums be standardized? Like, that last question is answerable using parabolas, right? But the difference, of course, there is we're using a parabola to look differently at baseball, as opposed to using baseball to contextualize quadratics. So I think once we as a community, as an educational community, start to make the distinction between using the world as a context for illustrating mathematical concepts and procedures, which is worth doing, but then also using mathematical concepts and procedures to talk about something real in the world, right? Where our real motivation is, what kid walks into class, he's like, what are we learning today? We are going to use systems of linear equations to analyze the pros and cons of increasing the minimum wage. That is what we're here to talk about today, right? And another day, we're going to talk about, we're going to use how long does it take to finish a milkshake to contextualize linear functions, right? Like we've been doing in textbooks forever, because there the goal is, to really get at this underlying mathematical principle. But I think we do need to start to inject, that the other direction. Does that kind of get at it?
It
Yes.
does. Yeah.
So this is really, nice. It's almost a cop-out to say both. First of all, what's critical is it's really easy for me to be quiet at this point, because there's nothing to be defensive about. And what some of you may know is that Karim and I are really, really good friends and have had these discussions for a very long time. I think that what he just said, really said that the issue is not that last thing of when we are looking at the parabola to make sense of baseball, that's the ideal lesson. That it is a series of lessons. And before you get to that, you've got to deal with the fact that some things go up and some things go down. And what's so amazing about that is that if I put a little 2 next to the X, it changes things. And so, there's no question but that when Karim talks about debate and about argument and about the ways in which mathematics is this tool for exploring and understanding the world, all I did was set him up, I think, purposely, I set him up perfectly to deal with the Vermont COVID stuff. This is not textbook math. This is data from the newspaper that affects these kids. Why is it that Vermont is so much better off? They were comparing Vermont to Louisiana. Again, only 1-2 lessons last week. I don't want to overplay them, but boy, I'd give an awful lot if people started there and then moved beyond that to the things that Karim's talking about.
This is a great conversation, and I think landed in a really nice place, right? It really is both. But the ultimate goal, right, which is what we're talking about here, I think we all agree, is not just the analyzing the data, right? It's not just that first step. There's another step that we often fail. So can we go and talk a little bit about where we see this go wrong? You've all been in a lot of classrooms, either as a student yourself or in your current role or former roles. What do we see going wrong in math classrooms, and why do we think this is happening, right? Obviously, everyone wants the best for our kids. Everyone wants our kids to all have the possibility of being an astronaut, right? We are infinite possibilities, and that's what every single educator wants. So what is going wrong, and why do we think so?
Well, I'll jump in with three quick things and let it go from there. I think that one of the most common things that I see go wrong in a math class is not asking the right question at the right time. I go back to a class that I watched actually with Laura at a Success Academy school years ago, where the critical question was, okay, given all that we've just done, can you express that relationship in a picture and in two equivalent expressions? And that was the right question to launch kids on paired work for 15 minutes that then had all the whiteboards spread around the room, sharing it. And it elicited just amazing understanding of this idea of equivalent expressions. And I just see a whole lot of places where instead of the right question at the right time, I see the other wrong thing is focusing more on the right answer than on the process or the justification. I'm a great believer, and you can go to my website and read what I've written about what I think are the 9 most important words in this whole business. I mean, if we transcend the idea of the ideal math class, I think that standard for mathematical practice number 3 is the only one that is found in science, English language arts, and math, and that is construct viable arguments and critique the reasoning of others. We're back to debate. We're back to the thinking, the reasoning, the important things that Dr. Harris was talking about begins with an answer. And then how do you know? Can you convince us? How else could it be done? And it's the making of arguments around whether it's data or situations or contexts that I think is missing in too many places and is this giant missed opportunity.
I have a lot of thoughts on this. I think there are two things. So first, I do think this is sort of a societal problem, meaning I think for years, and we think of math, and I'm generalizing, we think of math as the thing that you need to do to get the answer. And first, you have to understand the context or the situation, but that's not math. That's like reading. That's just understanding the situation. Then there's the math, which is the arithmetic. And then you're getting your answer. And I think that is just so ingrained in our culture that I think it's a really challenging thing to change mindset in teacher. But I think there's two things. One, I think oftentimes the richness of the problem, situation, mathematical model, whatever is in front of a student is not seen by the adult. They're not seeing the richness in there to discuss. And therefore, there's like an assumption that it's understood and we're just going to move on to the answer. So I think that's one. And I think the second thing is that, honestly, we're going to go here. I think assessments have played a huge part in this. I think standardized assessments, I think the way that we measure successful mathematicians has really, really done us harm, to be frank. And not that assessment isn't good, right? It's just the way in which we've kind of reduced it as a society, I think is problematic.
Yeah, I agree with that. And I agree with you that assessments aren't the problem, right? Because before No Child Left Behind, it's not like math class was awesome,
right?
But it does seem like we have, these tests were always intended to be the floor, and somehow they became the ceiling, and that has like exercised a lot of what could be really valuable experiences out of the classroom. Laura, you said something I think is wonderful. You were talking about math kind of always being the thing focused on getting the right answer. And, going back to Stacey, your question at the beginning, like what would we say the purpose of math class is? I'll just very quickly give you a bit of kind of my background. I started something called Mathalicious. We changed the name to Citizen Math because Mathalicious sounds ridiculous. And the purpose of it has always been to really put teachers in a position to help students use mathematics to talk about important issues in society rationally, health insurance, climate change, interesting issues like the shoe pricing one, but to really ground their reasoning in mathematics. And also, and this is really key, and I think comes back to Laura, what you talked about, is to recognize that most of the most important issues that we confront as a country don't have right answers, right? Like, should we increase the minimum wage? There are upsides and downsides to that, right? Should Major League Baseball standardize outfield walls? Like, upsides and downsides to that. And I think the part that so to come back to the question, like, where have I seen it go wrong, is I do oftentimes think that we as a math education community, and I was a math teacher and I did this as well, is we are very much focused on kind of getting a right answer, which presumes that there is a right answer to get. And when we do that, one of the things that I see often as now someone who, writes lessons around these real issues is, and I totally understand why teachers do this, right? But oftentimes they'll teach the lesson, right, where the kids will do the mathematical steps and the mathematical processes, but they won't do the last question, right? So I'll give you an example. Dr. Harris, you in your last slide, you were talking about kind of the future and quantum computing, and are we ready for the future, right? Are we prepared for the future? And that's a really good question. And it reminded me of a lesson that we have where what students are doing is they're looking in 3 different categories of human endeavor: warfare, technology, and communication. And they're looking at 16 of the most impactful innovations over the course of human history. So in warfare, for instance, in 300,000 BC, mankind created the spear. And in 40,000 BC, we invented the bow and arrow, right? And in 1945, the atomic bomb, right? And what students do is they calculate the time it was between each of these kind of major milestones. And what they see is these milestones start coming really, really quickly, right? So it's 260,000 years to go from 300,000 BC or negative 300,000 to negative 40,000, bow and arrow. But then like 42,000 years to go from shooting an arrow to being able to like incinerate the planet, right? And so that's mathematically, it's subtracting positive and negative integers, right? But the question at the end of it is, so what do you guys think? Like, are we innovating faster than we can keep up with the consequences, right? Which goes, Dr. Harris, it goes right back to your question, like, are we prepared for the future? But you maybe would be surprised by how many classrooms they get right up to that penultimate step, right? And then the teacher's like, well, we've done the mathematical work that we needed to do, right? And so lesson's over. And it's like, oh man, but no, the whole thing was a setup for this conversation. And I don't blame teachers for that. Rather, what I fault there is, again, we still tend to view the purpose of math class as looking at mathematics, as opposed to using mathematics to have, in this case, a huge conversation about kind of the sustainability of ourselves as a species and autonomous robots and all of this stuff. And so I apologize for taking so much time, but I mean, that is, I see that kind of dropping the ball right at the goal line, right? As it's such a missed opportunity. But when you include it, when you reinsert it, and when teachers give themselves permission, or even better, when administrators give teachers permission to prioritize real conversations about real issues where mathematics is kind of the tool that they're using to do that, suddenly everything changes, right? Like when a 7th grade teacher in this case walks into a classroom and says, my goal today is for us to use integer subtraction to talk about whether we're innovating, kind of what are the consequences of innovating as quickly as we do. When a teacher goes into it with that mindset, teaching changes. It feels different to be a math teacher. It certainly feels different to be a math student, right? But I think in my experience, having taught a lot of these lessons, having heard from a lot of teachers who do, I mean, Laura, you can probably speak to this as well. Like, I think teachers find a new gear. And it's not because the lessons are that awesome, although, I mean, I think they're pretty awesome, but I think it's because mathematics is such a useful tool. And when we turn mathematics around and we use it as a lens that we're training on the world, like the world is so interesting. So let's just not fumble the ball.
True, when given the time and space to do so, which I think you said.
Yeah.
Because if not, then it just feels like overwhelm. Oh my gosh, I have to figure out how to teach this complicated lesson.
Yeah, time is, and that, I think that goes back to your point about testing.
Yeah, and space, right? Space to prioritize this.
Although I would say, I think it becomes kind of a self-correcting. So historically, here's what I did when I was a teacher, right? I offer up students a problem that very few humans would intrinsically care about, right? How long is it going to take for the trains to reach the station? And half of the kids are like, don't care, right? Half. 100% of the kids are like, don't care, right? And maybe there's one who just really likes trains. But most kids are like, I don't care. You know, how long does it take to fill up a water tank? How many pennies fit in a circle? Like, how many marbles fit in a jar, right? Like the types of problems that tend to characterize math class. Don't care, not really particularly interested in doing this problem, right? And so a lot of those kids then drop out, they disengage, they don't do the work, they don't learn the concepts. And so what does a teacher do, right? Teacher's like, well, I guess I have to reteach this unit, right? And I mean, we see this all the time, right? It's like we're going to double block algebra, which is basically, we're just going to do the same thing twice over, oftentimes, right? And so I think actually, if you really incorporate, especially if you incorporate them early, like we're going to use mathematics to talk about something real, right? How long does it take to burn off a Big Mac or whatever? If you lead with something real, I actually think that buys you time on the tail end, because kids are invested early. And you can use those to contextualize a lot of these concepts, even though that isn't the goal, right? You're kind of helping students develop informal knowledge around tables, graphs, and whatever else. So I think it ends up kind of solving the problem that gets compounded when we don't do it. That's been my experience anyway.
I just think we have to be very clear that the reason why we have to have lots of different contexts and be doing this more than just once is that all context is fraught. That is, some contexts are biased towards some kids, some are biased away from some kids. That the coolest thing in the world for me is something that turns off half of my class. And we just have to understand that nothing works for all kids in the same way that in language arts. I mean, and in reading passages on tests, there are some that attract kids and some that, in a sense, repel them. And that's why we can't expect all kids to just go, oh, this is the coolest thing ever for everything we do. But over the course of a month, even a week, there are enough opportunities for kids to say, oh, that was cool, you know, and I forgot about the thing that didn't work.
You know, as listening to all of you talk, the big question in my head is, all right, so if we buy into this concept that we need to change the way in which we are teaching, how do we change the mindset of the educators who have gone through, you know, colleges of education, being taught a certain way in the traditional way? How do we change that mindset in order
the answer, and this is a little simplistic, but it's the right question. It's the question that everyone asks. And I think people cannot do what they can't envision. And we have untold mountains of professional isolation in this business. People teach behind their own closed doors. They don't observe each other. They don't work collaboratively. It's the direct opposite of all of your experiences as a medical professional, as an astronaut. And we sit there and we've got to find ways that in every school, teachers are regularly interacting, teachers are planning together, teachers are co-teaching. We need coaches in ways that we don't have coaches to bring additional ideas. A coach doesn't tell people what to do. A coach co-plans, co-teaches, and co-reflects with a teacher. A coach says, you know what, no one can change by more than 2 things in a month. These are the 2 things to work on. And anyone that thinks the teacher preparation is going to solve any of these problems, I think we all know that's not the answer. It is what happens within schools, within departments, within grade level teams that makes all the difference. And we have some wonderful examples in this country, but they're few and far between.
I think I interpret Dr. Harris's question as being a bit bigger, because that seems like a very tactical answer, and I agree with pretty much everything you said. But I interpret his question as, you know, we have hundreds of years of thinking about mathematics in a very math education in a very specific way, and how do we go beyond that? Especially getting back to what Laura said, especially given that the tests, you know, are assessing exactly what's being taught in school, right? So it's not like anybody has any immediate need. I think there are a couple different answers. One is you know, honestly, like, look at us as a country, right? We just lost 700,000 people because we couldn't have a rational conversation about how pandemics spread through a population, right? And in 2009, and I mentioned 2009 because this is the origin story of citizen math. In 2009, we couldn't have a rational conversation about health insurance, right? Health insurance is fundamentally discussable using expected value, probabilities and percentages, right? And so I think the 1,000-foot answer to that, how we encourage people to kind of think beyond the narrow channel that kind of math class has always been, and it's like, yo, look at the country. Is this sustainable? Because as hand to God, anybody who is watching this who is a math teacher, cable news, advertising-driven news, has no incentive to really challenge us to think critically as a country. School is all we have. And math class, because it is such a powerful tool, math class is the best place. Laura used the word incubator earlier. It's a perfect word. Math class is the perfect place to incubate a citizenry that can discuss these issues more rationally than we as adults are, right? So I think that's the 1,000-foot, like, we got to save the country here, and you're the ones to do it. Now, there's still going to be a lot of people who say, yeah, but like the state doesn't tell me I have to do that. And in fact, that's not what I'm held accountable to. And so then I think the second question becomes a little bit more immediate, which is, why did you become a teacher, right? Open up a textbook. How long does it take to drink a milkshake, right? Or what's the square root of q to the 9th? Is that why you got into teaching? Or do you also, not instead of, but do you also want to have a conversation about, for instance, the impact so a lot of cities around the country, you get a speeding ticket. If you can't pay off that speeding ticket in the first month, the municipality in many places starts to add a monthly fee, right? So do you as a math teacher want to have a conversation where students are using linear functions to discuss the impact that has on high income people versus low income people? And what are the fairer ways, what are the fairest ways for municipalities to raise money, which they have to do, but in a way that doesn't put an undue burden on, you know, impoverished communities? Do you want to have that conversation as a math teacher? Is that something you want to be part of your legacy? And so I think, Dr. Harris, I'm so glad you asked that question. And personally, I mean, I think that the answer is just to kind of tap into, you know, teaching is so big. It's like other than parenting, it is probably the most impactful role that we have as a species, right? And yet, I think we as a math education community have settled for conversations that, you know, serve a pedagogical purpose, but they're kind of boring, right? Like, how many marbles fit in a jar? Like, you know, we can do better than that, right? I think when we tap into the deeper motivation for becoming an educator, because it's certainly not pay, right? Like, anybody who's been a teacher, we know it's not that. Like, I think it is something higher and deeper. And I think that's it. And when teachers, in my experience, I mean, when teachers come out of a classroom saying like, man, we just used expected value to have a really valuable conversation about whether we should have an individual mandate, right? Or kind of the trade-offs between having mandatory vaccines and not. You know, I think that's when people are like, oh man, I want to do this. Even if the state doesn't require it, this is why I became a teacher in the first place.
As you were talking, and you know, I too see, you know, television, daytime television, and the cable shows is a great. How can I say this nicely? It reduces us to the lower denominator, right? It assumes that we are dealing with a population that can't handle, you know, critical thinking. And in some cases, it's true. If you look at that, because they have found that sweet spot that just speaks to the group of us that don't want to think critically and want to be told what to do. I cannot think of anything more relevant than what we're talking about today, in terms of, you know, math being the epitome or the symbol for critical thinking. If we can increase that within the population of the United States, we, this country would change.
So
Totally.
let me just grasp at just trying to be a little bit less pessimistic and a little bit more positive about all this stuff. I mean, it seems to me that there are some partial, powerful answers to doing the things that we're talking about. I believe that you can capture so much richness and depth in a class when you are hearing over and over again, why? Why is that? How'd you get that? Who did it differently? I love it when teachers say to whatever kids say, whether it's an answer or it's a paragraph, it's a solution, can you convince us? The whole notion of who did it differently, the whole idea of can you explain it differently? Who agrees, who doesn't, who disagrees? We could build so much in terms of student power with how are they the same? How are they different? And those questions tend to be missing. It goes back to not asking the right questions, and it goes back to missing all those opportunities. And so I know that some of this is incredibly complicated, but there are parts that we see in classrooms where there's real learning and engagement taking place.
The only thing I would add to that, Steve, is that the asking why, what's different, how are these the same, has to be about something meaningful. Because I see a lot of times those questions being asked because we know we're supposed to ask those questions, but it's about something that is not meaningful, and it becomes sort of it. That's where all kids just check out.
Yeah.
But I mean, we've all seen number talks, where there's just two numbers on the board, but we've also seen number talks where, there's a context. I mean, so, there are 46 students in this grade and there are 49 students in that grade. Good. Turn and tell your partner, how many are there altogether? And all of a sudden it just became students, and it is not a particularly engaging context, but the fact that there are 7 different ways that kids are able to add those numbers and have a discussion that tells us a great deal about their depth of understanding of place value and estimation and rounding and all is what I think undergirds so much of what we're talking about. It is really hard to do all the magnificent work and problems and tasks and lessons that Karim is talking about and that Karim has dedicated 10 years of his life to doing if there isn't first a sense of fraction, a sense of number. I love the expected value as a way of dealing with insurance and the mandate. But if you have no idea about probability, no idea about fractions, if the idea of expected value is alien, then you never get there. And so that's where I think sometimes we got to make some compromises, and not everything is just filled with an eagerness to learn it.
I don't know if I said something, I'm sorry if I said something that seemed pessimistic. I mean, it seems like Dr. Harris and I don't want to put words in your mouth, but it seems like we agree that that math teachers have this unique opportunity to save the country, really. I mean, to help students do what a lot of us as adults aren't doing, which is really thinking about things rationally and looking at them from multiple perspectives. I think that's incredibly optimistic to say that if you're a math teacher, you can save this country, right? I mean, you might say, oh, it's cynical to say that we're backsliding, but I imagine pretty much anybody watching this would agree that we're backsliding. Now, that being said, I'm looking, there are a couple comments, and some people are saying, math doesn't always need to be practical, and that's absolutely true. And Steve, I think to some extent you're making this point, right? It's like, no, we can appreciate the beauty of mathematics for mathematics' sake. I mean, that is what the mathematician's lament is about, right? And mathematics is incredibly beautiful. But that being said, it seems like math education has always accepted that, right? Like it doesn't seem like that's an argument that needs to be made at this point, because math, I think if you polled most math teachers in the country or in the world, and you said, what is the purpose of math class? Which, Stacy, you asked in the beginning, I imagine most people would say it's for them to understand and appreciate the beauty of mathematics. And that to me makes a lot of sense. And it's also like saying it's to appreciate just how beautiful telescopes are, right? And to open them up and just appreciate the elegance of lenses and the way light reflects and refracts, and just to appreciate that. And yep, that's true. And I think we as a math education community have always agreed with that. But it seems like the territory that we need to claim, and this is, I think, why I maybe sound more dogmatic, is because let's turn the telescope around and actually look at the world. I don't know why, but that is the piece that's always been missing. And what's interesting is I think we often we assume these two things operate in tension with one another, right? Like it's either real, like authentic real world math. I'm not talking about contrived word problems, but like we're really talking about the world, or it's pure math. And I think if you prioritize both, you allow both of them to be as pure as they can be, right? Like, yeah, prime numbers, like why is it that prime numbers appear in pairs? Or, oh, I think it's incredibly beautiful that the derivative of an exponential function is exponential. Like that's fascinating just in and of itself, right? And so I think if we say, on the days that we're going to use mathematics, talk about the world, like we are going to use exponential functions to analyze how video game consoles have changed over time, right? Whether they're following Moore's law. And we're just going to talk about like, are video games becoming so realistic that we're at some point going to be able to distinguish them from reality? Like, what are some of the consequences of that? We're here to talk about that. And then on another day, right, we're going to talk about the derivative of an exponential function. I think it's only when we include both of those that either of those kind of gets the honor that it deserves.
I just want to throw a plug in for Karim's book that you put in the chat. I have listened to Karim. We've had these conversations. I've listened to the issue of the telescope now for almost 5 years. I didn't understand it the first time or the second time or the third time. I read the first draft in the book and I told him that he still didn't hit it out of the park. What is in the book right now is the elaboration of what you just heard him say in a number of different cases where it just makes so much sense. And so I learn more through my eyes than through my ears. And so hearing this may work for all of you, but I'd be remiss if I didn't tell you that you are missing out on an incredibly important journey if you don't get your hands on Dear Citizen Math and explore it.
Thank you for saying that. And you were extremely helpful. Thank you for that help.
Whatever. Cool.
We've got a lot of questions coming in the chat, and I'm really excited about them. We've got some great comments in the chat, so I'm having trouble kind of doing both at the same time, but we are going to save all those chats, and we're going to make sure we get back to you on a lot of them. There's a lot of questions about coming from educators working in schools who want to know what can they do to really help start this, whether it be supporting teachers to do this or doing it themselves. So what's one practical, if I'm an educator working in a school, where do I start? What's one thing I can do? And I know we shared some of these thoughts already, and I know Steve's talking about some great questioning, but I would love to hear from everyone.
Honor mistakes. You can't learn without making mistakes. And we make mistakes bad. And kids are always telling me, oh, I made a mistake. I can't tell you how many lessons I've observed. A teacher makes one mistake at the board and then freaks out. And that's all they want to talk about after the lesson. The fact of the matter is, people make mistakes. We grow from mistakes, and we ought to honor those mistakes. It is what happens in life. And to make math this thing where you should be feeling bad and incompetent because you made a mistake is the dumbest thing that we could possibly do.
I mean, I think go back to the purpose of math class. Like, go back to what is the purpose of this? What are we doing this for? What is our vision? I'm a firm believer that we are not trying to teach people all of the decisions to make, but instead teach them to be decision makers based on a set of mindsets and values that will drive towards this goal.
Well, I don't know how to answer this question without sounding like a product pitch. And so, but if your
That's a
goal,
question too that's going to come up, so go for it. You'll answer both questions.
well, honestly, I mean, if your goal is to add this new dimension of math class where students are using mathematics to talk about real issues in the world, and if you want to do that in a way that that respects the rules of school, right? So lessons are teachable within 2 or 3 days, and they align to a unit, and they're going to help build conceptual understanding and procedural fluency, even if that's not their goal. Like, I'll say, like, I think the one thing you should do is use, I feel so uncomfortable saying it, I think you should use citizen math lessons. Just because it's concrete, and it is a stepping stone for people who want to do something different. I mean, that's why we made it, right? I mean, we've all been teachers. We made it for teachers to help them, do something different. And forgive me for, referencing the thing that we created, but.
Well, that's why you're here. We use it. We love it. And we love the work that you're doing. Dr. Harris, anything on that?
Well, I'm going to follow Karim and talk about the work that we do in math. As you know, the National Math and Science Initiative is involved in STEM, and math is a critical component of that. And so we do have an algebra program because we think that that's a critical course that needs to be emphasized. And so we've been focused on that in addition to all the work we do K through 12. So if you want to learn more about what we do, just please go to NIMSY, nms.org. How about that, Karim? You feel better?
I do, thank you.
So
I'm not going to sing the praises of anything that I've written. I'm going to simply say that if you really care about all these things and you care about kids, number one, you will seriously entertain detracking. We would go back to heterogeneous groups. There is nothing that is more, it's just disastrous than the missed opportunities and the lack of opportunities for kids that are tracked into lower levels. And I think that 6th grade is the single most important grade in the entire curriculum. If 6th grade sucks, it is almost impossible for kids to catch up. The Common Core gives us a 6th grade curriculum that is so rich and so important. And again, you can go and read about my thoughts on 6th grade on my website, but what's important here is to understand that there really are solutions, there are steps that we can take that help us get to the kind of consistently engaging classrooms that we've been talking about.
what are some other obstacles that are in the way of, I mean, we spoke about this somewhat, but what else is getting in the way of math class being what it could be? I know we've shared about assessment, we've shared about their antiquated understandings of what math class could be, but what else?
Well, there's some horrible things that have to be said, and that is that one of the biggest problems we have is that education is still run by upper class people, increasingly upper class women who were very successful and believe that their kid needs to have the same privilege that they had. And they do everything in their power to establish policies that maintain that privilege. That's why there is tracking, and that's why there still is an obsolete curriculum. It worked for me. How could my kid go to a school that didn't do 3-digit long division that no one does? Why would they didn't use calculators in Desmos when in fact that's not for the SAT? And so until we have a deep analysis and understanding of how decisions get made in some, thousands school districts, we're going to continue to have problems. And there's little that drives me crazier than when teachers have got to become subversive in order to serve kids the way we're talking about. And that's a reality in too many places. And that's hard. It is unfair to ask people to be as subversive as sometimes I ask them to be.
So I think of 3, and I'll try to say them really quickly. I think the first piggyback sort of on what Steve was saying is just institutional inertia. I think, the first obstacle is if we're unwilling to think about mathematics differently, or add this new, like we've always thought about mathematics as something to look at, if we're unwilling to prioritize also mathematics as something to look with, I think that's the first obstacle, kind of just institutional inertia. The second obstacle, if what we're talking about is using mathematics to talk about real issues, including issues that are political or including issues that are socially kind of sensitive, I think the second obstacle is being political, right? I think it's really important that math educators go into these experiences really just with their only agenda saying, we're going to use mathematics to look at this objectively as one can, and not have an agenda with it. I know how frustrating that can be given a lot of the issues that do exist and how passionate a lot of us are about kind of helping rectify some of them. But of course, the danger is twofold. Like one, somebody just all of a sudden tells math teachers to get in their lane, and then we've shut that whole thing down. And then the other is, math is a tool for objectivity, and it is a tool for kind of rational analysis. And I think we have a responsibility to the tool to approach it like that, independent of whatever our personal politics may be. And then the third one, and this is the one that as an American just scares me to death, is computers in school. And what I mean by that is, if our goal is to help incubate a society that can have a rational conversation with itself, then we have to prioritize classrooms as places for kids to come together and have social discussions. And the more we adopt these computerized algorithms to sort of take the place of a teacher, the more time kids are spending staring at a computer screen, right? The less opportunity there's going to be to have those conversations. The more we invest in $40 a kid, personalized learning, the less we're investing in professional development and high quality curriculum, the worse teaching is going to become. And then the more we're going to have to spend on these computerized systems. And so that for me, it just absolutely terrifies me, that we get to a place where we essentially turn school into an app store. Because at that point, I think we might as well just fold it up and go home. I know that sounds simple.
Well, as everyone knows, there are two sides to that. It's like every other piece of technology can be used and abused. And I hope that, I know you well enough to know that you're not saying that the apps are the problem. That the problem is there are some crappy apps that are used, but there also are apps that can be used wisely and effectively.
Yeah, I just think technology is such a slippery slope that I think in a lot of places, you're going to start seeing kids being like, you know what, path of least resistance. Let's just have the kid sit on personalized learning for 6 hours a day. And at that point, it's the ballgame.
Well, I think we also,
yeah.
Go ahead, Doctor.
I was just going to add one thing that I think is an issue with this country is equity amongst teaching and community. And so if you look at the Black and Brown community, as I showed in my presentation, there's just this big chasm that's developing. And that is something we've got to address in this country. And if we don't, we're going to lose, whether you are a white male or not. The bottom line is that we need to invest in all of our communities, and we're not doing that.
Yeah.
It's not an equitable way.
No question. We're back to the property tax, and as somebody put in the chat, capitalism is in the process of killing education. And I think that a strong case can be made that that is the case. We've forgotten that education is a critical public utility, a public service, and we've forgotten about that. Can I just do one thing? I mean, Stacy, I can't tell you how embarrassed I am right now. Did I miss the invitation that said we're going to 5:30? I thought this was 4 to 5. I mean, I'm sitting here going, I have dinner reservations and theater tickets, and I did not know when this is ending. Now that's ridiculous to have on this tape, but that's where I'm at right now.
No, we are ending. And we understand everyone has busy times. It's hard to cut you guys off because I want to continue this conversation, but this is just the beginning of the conversation. This was intended just to be the start of a conversation. You have all of the contact information, the websites, the Instagram, the Twitters, every one of the folks here, and we encourage you to continue this conversation.
Please ask people to submit questions that we did not ask, we did not answer. And I'd love to come back and join this amazing group of people another time to really hone in on the questions that we didn't answer that people have.
Absolutely, and I appreciate that. And I will just say for those educators on the call, we do have follow-up math workshops where we'll bring folks into Success Academy schools virtually to see how we bring our lessons to life through planning meetings, through teaching, highly recommend if you are an educator, you want that information, we'll put that in the chat. We'll also be releasing some of our elementary school and middle school curriculum. And so we really want a chance, if you want to look at that, go ahead. We're going to put that in the chat as well. You'll get a chance to see a little bit how this plays out in our schools. And again, we'll bring that to life in those workshops that are following up. We also want to just thank all of you for being here today and for bringing your thoughts, your ideas, your perspective to this conversation. We hope this is the start of the conversation, not the end. And we look forward to continuing to work on this problem together. But thank you all for being here. We really appreciate it.
My
Thanks for
pleasure.
having me.
Bye.